I've got some great news, and that's this. We've gone through several videos and labs on configuring IPv6 and also configuring static routing for IPv6. And we just got a call. Let's imagine we got a call from Bob who said, hey, in our production network, we need to implement some basic IPv6 static routes. Can you help us? The answer for this case study is absolutely freaking yes. Let's take a look at their topology, and then we'll make a plan, and we'll implement IPv6 static routes on the network. So as we walk into Bob's office and he explains what they're intending to do, here is the table that he has shown us. It has R1, R2, and R3 right here. R1 in Arizona, R2 in Nevada, and R3 in Florida. And they currently have all of these IPv6 networks configured on their respective interfaces. So for the Metro Ethernet network that's common to the Nevada, Florida, and the Arizona routers, that's off of interface 2/0 on R1, which is this bad boy right here. So it's 2001 DB8 6783 1607, and then for the router numbers, R1 is going to end in 5, R2 is going to end in 6, and Florida R3 is going to end in 7. And so if we add the networks here, and I'm just going to put this portion of the IP address just for documentation brevity here, so we can see where those networks are. Over here off of R1, we have the 1606 network. Over here off of Nevada, if we take a look at that, we've got the 1608 network. Over here off of Florida, off of its gig 1/0 interface, we have the 1616 network. And then the Metro Ethernet that's connecting them all together, for that one, they're using 1607. Again, referring to this section of the IPv6 address. So with that brief explanation from Bob about what IPv6 networks exist, we then ask Bob, so what exactly do you want us to do? And here's what he says. What he tells us is that they want IPv6 connectivity between those three networks, 1606, 1608, and 1616. Again, we're pointing to just this portion of the IPv6 address. Now, in the skill on IPv4 static routes, what we did for simplicity was we on Nevada had, on the R2 router, we set up a default route that pointed to R1. On R3, the Florida router, we did a default route that pointed to R1. And then we did two static routes, one that pointed to Nevada with R2 as the next hop, and one that pointed to Florida with R3 as the next hop. And you know what? If it worked for IPv4, we could use that same plan for IPv6 as well. So let's make the plan for R1, and then the plan for R2, and the plan for R3. And then once we confirm the details for that plan, we'll go ahead and implement it in this case study. And just like before with IPv4 static routes, when you complete this, whether you do it in Packet Tracer or some simulator or emulator or use our live labs, I'd like you to give yourself 10 points and keep track of those for every case study. At the end of the skills that we do, give yourself 10 points for each of those that you complete. And the goal is to get to 100 points. And that 100 points will not only be fun to get to, but it'll also represent a whole boatload of skills that you've gained along the way in getting that point. So let's go to our plan for R1. For R1, we want two static routes. We want to route to 1608, so it would go something like this, IPv6, route, space, and then I'm going to put 1608 in the interface. We're going to put out the whole IPv6 network, /64, and then space. The next hop from R1's perspective to get to those networks is going to be Nevada. So I'm going to put R2 there as the next hop. So R2's interface 00, if we look at the chart, is going to be the 1607::6 address. So that's a static route for Nevada's network of 1608, and let's add one more for Florida's network of 1616. So that would be IPv6 space, route, space, and then we put in that network that we're trying to reach, this 1616. Of course, in the interface, we'll put in the whole thing, /64, and the next hop, we're going to put the IP address of R3's 00 interface, which is right here in the table. So R3's 00's interface would be this long one right here, 1607::7. And boom, we're done. And then on R2 and R3, we could just do default routes. IPv6, route, space, and then we'll use the ::/0 space, and then we'd put R1's address here. And then we'd replicate that over here on R3. And then once we have that in place, we can test our IPv6 connectivity between those three networks. So we'll go to our admin PC here in the virtual lab. We'll go to DC-nug, and we'll open up MT Putty in the upper left-hand corner. And then we'll proceed to click on the Servers tab here on the left, and we'll open up connections to R1, R2, and R3. All right, with those connections opened up, let's go ahead and start on router 1. So the first thing we ought to do on router 1 is do a show IPv6 interface brief just to verify that we have the IPv6 addresses that we believe we have in place and ready to go. So here's its IPv6 address on gig 00, and here's the IPv6 address on gig 20, and it's that 20 interface that's connecting to the Metro Ethernet network. So we'll go into configuration mode and type in IPv6 route, and let's do the first route for 2001:db8:6783, and then the network out in Las Vegas. Let's take a look at our topology. So that network is going to be the one in that fourth grouping, which is 1608. So we'll put in 1608:/64, and then the next hop is going to be R2's interface on the 1607 network. And to avoid typos, one easy thing we could do is we could go over to R2 and just do a show IPv6 interface brief and just grab the IP address here. So I'm going to click and drag across this IP address, and that puts it in the buffer, and then we'll go back to R1 and we'll right click as the next hop. Boom, one down, one to go. Let's go ahead and take care of the route over to Florida. So looking at our topology again, that's the network 1616. And the next hop from R1's perspective is going to be R3's 00 interface on this 1607 network on the Metro Ethernet. So we'll type in IPv6 route space 2000. In fact, I'm going to copy some of that. Save me a little bit of time, so we'll go ahead and copy up to that point. Right click, and then that's the 1616 network :/64, and the next hop is going to be R3. So I'm going to copy paste that with the correct IP address in that last grouping. And then what we're also going to do is we want to verify that what we think we put in actually got put in. So we'll do a show IPv6 route and press enter. Now, one thing that I do all the time, because we work with IPv4 so darn much, is I'll be working on IPv6 and I'll do a show IP route, press enter, and then I have this huge routing table, connected routes, OSPF routes. We'll cover OSPF in a separate skill. Static routes, and I'm like, whoa. And I realized I did the wrong command. IP refers to IP version 4. If we want to look at the IPv6 routing table, we need to tell it, show IPv6 route, and press enter. And then furthermore, if we do an up arrow and show IPv6 route space, we can just go ahead and ask to show just these static routes, and it'll do that as well by using the keyword static. So here's our two static routes. To get to the 1608 network, which is up in Nevada, we're going to use the next hop of 1607::6, which is R2. And to get to 1616, we're going to use the next hop of 1607::7, which is R3. That looks great. Let's go configure the default routes on R2 and R3. And I'm just going to copy the first big part of this because it's going to be used so much. And that way I can copy and paste it as we go. So over here on R2, we'll do a show IPv6 route, see where we're starting. Great. And then we'll do a config T, typed in correctly. And we'll type in IPv6 space route space ::/0 space, and with the next hop of 1607::5, which is the IPv6 address of R1 on that Metro Ethernet segment, and press enter. And then we'll take a look. Show IPv6 route static, just to make sure it got in. There's our default route. There's the next hop. That looks good. And let's go to R3 and we'll do the same command. In fact, I can just copy that because it's going to be the exact same command on R3. So we'll go to R3, show IPv6 route to start, config T, and a right click to paste that in, and show IPv6 route. All right, so there's our default route with the next hop of 2001:db8:6783:1607::5. All right, so now let's talk about how we could do a valid ping to verify end-to-end connectivity. And here's what I propose. We should do a ping and source the ping, if we're doing it from R1, source it from this interface on 1606, which would be the gig 00 interface. We could source it from 2001:db8:6783:1606::5, which is over here in the Arizona networks. And then using that source, ping the Florida interface on 1616 and or the Nevada interface on 1608. So let's go ahead and do that for a connectivity test. And because we're sitting here on R3, let me just go ahead and grab R3's IP address here. This local route will give us the full 128 bits. So that's the address that we want to ping from R1. And so if we go back to R1 and we type in ping space, Now, we don't have to use the keyword IPv6 because when we put an IPv6 address, the router says, oh, I get it. That's an IPv6 address. And we'll put a space, and then we'll source it. And we'll source it from our local 1606 interface, which is shown right here. So I'll copy paste that as well. And let me just verify that real quick. So we're pinging to the 1616 network, and we're sourcing it from the 1606 network. And let me take a look at my topology, make sure we're spot on. Yep, okay, so from 1606 to 1616 looks good. Let's do the ping. So we'll come back to R1, press enter, and the crowd goes mild. So let's also do a ping out to Nevada. So we'll hit the up arrow key, and this time we'll ping the destination of 1608 with the destination of 6 in that last grouping, which is an interface that R2 owns, and then we're sourcing it from our internal network still here on R1, and that looks good. We'll press enter. And sure enough, we have connectivity to those remote networks and back. I guess one last thing we could do is we could go to R2, and from R2 we could try to ping R3. So let's do a show IPv6 interface brief. And then for R3, let's go take a look at its interfaces real quick. So here we go. We have 2001 DB8, 6783, 1616.7 is our target. So we'll put that in our clipboard. We'll go back to R2. We'll ping that destination, space, and then we'll source it from our local network, which is this guy right here, 2001 DB8 6783 1608::6, and press enter. And survey says, that is not flying. That is not working. Okay, let's try to ping without sourcing it. And that'll ping it, sourcing it from the Metro Ethernet interface. And that is not working. Why is that not working? Honest question, why is that not working? Let's take a look at our diagram. Again, when we do a real world case study, sometimes it's pretty much real world. So let's think about this together. All right, so let's take a look at what does work and what doesn't work, and then we'll troubleshoot this together. That's why this is a real world case study. So what does work? R1 from this network here on the inside was able to ping Nevada back and forth, no problem. R1 was able to ping the Florida networks back and forth, no problem. However, when we decided to try Nevada pinging Florida, that failed. So what should happen is Nevada has a default route. So when Nevada is trying to ping the Florida networks, the packet should be forwarded to R1, who should then know how to reach Florida because it has those two static network routes, and it should forward it over to Florida. It just occurred to me what's happening, and I'm so glad that this happened here in this case study, because although we configured static routes, the routers are happy to forward packets that they're generating to the other side. However, unless we enable IPv6 unicast routing, these IPv6 routers are not willing to forward traffic on behalf of other devices. So what we need to do on each of these routers is go into configuration mode and do IPv6 space unicast dash routing. That's what I believe the problem is right here. Because R1, when he gets the packet from R2 and says, oh, this isn't my traffic, I know how to get to the Florida networks, but I don't have unicast routing enabled for IPv6, so I'm not going to do it. Now, we've covered and talked about IPv6 unicast routing in previous videos as part of the skill, but now here in this case study, it's really important that we implement it. Otherwise, these routers will not forward traffic for another device. That's what I think the problem is. We're going to leave the camera rolling. Let's go enable that on all three routers, and then we'll take a look. So here in R2, we'll go into configuration mode, IPv6, unicast routing, enable it. Fantastic. We'll do that on R3 as well. And IPv6, unicast routing. And we'll do it on R1. In our topology right now, it's R1 who's causing us the grief, I believe. So we'll do a config T, IPv6, unicast routing. And now that that's enabled, let's go back to where the ping failed earlier. So back to R2. So here's our timeout. And I just used the up arrow key a couple times. So if it indeed was the IPv6 unicast routing that was missing, and now we've enabled it, this ping should work. Cross our fingers. Let's give it a go. So back at the CLI, we press enter. So I'm super glad that that happened here in this case study, because if it happens here, well, we have the opportunity to see it and ponder it and then correct it in the production environment when it comes time to do IPv6 routing and you're putting in a static route and it's not working for some reason. You're going to remember. It's like, oh yeah, are these routers enabled for IPv6 unicast routing? And the chances are they're not. So you want to enable that as well. So I've had a lot of fun in this video and case study on implementing and verifying and troubleshooting IPv6 static routes. Like our previous skills and the case studies there, like IPv4 static routes, if you've done this exercise, whether it's in Packet Tracer or GNS3 or Viral or LiveGear or anything else, if you've completed the exercise as we've done it together in this case study, give yourself another 10 points and keep track of those. The goal is to get to 100 points. And not just to have the 100 points, which is pretty cool bragging rights, by the way, but also as we accumulate those skills and experience on the way there, we're going to be really, really good as we continue to grow and enhance our skills at troubleshooting, configuring, and working with IP networks, which is the goal of this training. So I'm glad you're here for the journey, and I'll see you in the next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.